All right, here we're looking at section 9.5, and we're still solving our quadratic equations, but here today we're going to solve quadratic equations using the quadratic formula. Now the quadratic formula is something that will work no matter what. We've looked at several different ways to solve quadratics, right? Either by factoring or by graphing and then completing the square and using square roots, and now we're going to use quadratic formula. This one works no matter what, so this is something you need to actually memorize. Then our second learning target for today is to interpret the discriminant and see what it means. And then we're going to choose efficient methods for solving quadratic equations, because some quadratic equations are very easily factored, and so that's going to be the fastest way. So we want to factor those. Others can't, so we're going to look at some methods to how we determine which way to solve them. So the first thing we want to look at is the quadratic formula. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This is something you need to know. Just put this into your brain right now, sing it over and over and over, make it go in there because you're going to use it a lot. So now let's actually go ahead and use this quadratic formula. So the first thing I need to know is what my a, b, and c are, and then I can plug them into the quadratic formula. Okay, so here's my quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. So now I substitute in the values, and always when I'm substituting, use those parentheses. So my a was 2, my b is negative 5, and my c is 3. So I substitute in and then I simplify. Well, then I can evaluate this square root. Because I know what the square root of 1 is, I can go ahead and simplify and evaluate. So now I have 5 plus or minus 1 over 4. So here's my solutions. So 5 plus 1 divided by 4, and then 5 minus 1 divided by 4. So my two possible solutions are 3 over 2 and 1. Then I have to always go back and double check, because sometimes we don't have a real solution. So I plug both of those, my 3/2 and my 1, back into my original equation, and then I simplify and see that yes, both of my solutions actually work here. So those are both possible solutions. So now here you're going to be solving a couple using the quadratic formula. Here I'm asked to round them to the nearest tenth. So here's, I can go ahead and use my calculator to find that. So go ahead and try these. So now let's look at kind of a real world problem. So the number y of northern Rocky Mountain wolf breeding pairs x years since 1990 can be modeled by this function. And I'm given the graph of this function as well. When were there about 35 breeding pairs? Well, so I'm given a quadratic function, and I have to figure out when, so my x, when there were 35 pairs. So I can go ahead and substitute that 35 for y, and then I'm going to solve for my x. So I substitute for my y, and I write this in standard form. Right, so I get everything over to one side, so it's equal to 0. Well, I look at this and I see this is probably not going to be easy to factor because I've got decimals. So I'm going to go ahead and use the quadratic formula. So I write out my quadratic formula, I substitute my known values, and then I simplify. So here, now that I'm still dealing with a bunch of decimals, I can go ahead and simplify again. I find that the square root of 33.64 is approximately 5.8. So now I can again find my two possible solutions. So I have either x is 10 or x is negative 19. Well, looking up here, I can see that this negative one doesn't actually make sense because I'm just looking at years since 1990. So I want to kind of determine which of my solutions there is. So I can use my graphing calculator to also double check where I was looking at, and I said it was at 10 years, right? Because I don't care about this negative one, because I'm looking at since 1990, so I'm only looking at my positive value. So I can just double check using my graphing calculator at my intersect. You can do this on Desmos as well, if you want to just double check your solutions. So now here's your next monitoring progress that you can try and see what you're looking at. So now we're going to be interpreting the discriminant. This was our second learning target today. So the discriminant is the stuff that's underneath the radical sign in the quadratic formula. Okay, that b squared minus 4ac. So if I have my b squared minus 4ac, if that is greater than 0, I have two solutions, right? And that's where it crosses my axis twice. You'll see a picture right here. If that discriminant, my b squared minus 4ac, equals 0, then I have one solution. That's where the vertex is on my x-axis. If b squared minus 4ac is less than 0, you're not going to deal with solving many of these. I have no real solutions. You see my parabola doesn't cross the x-axis at all. So I can use this determinant to figure out how many solutions I'm really looking at. So here's our first example. Determine the number of real solutions of this quadratic, x squared plus 8x minus 3 equals 0. Well, I'm going to go ahead and use the discriminant, which is b squared minus 4ac. So I substitute in my a, b, and c values, and I simplify and solve, so I end up with 76. This is greater than 0, so I know I have two solutions. So now let's look at b. Determine the number of real solutions of 9x squared plus 1 equals 6x. So the first thing I always want to do is write this in standard form. So get everything to one side. Then I can use my discriminant, b squared minus 4ac, and substitute the values that I have and simplify, and I end up with 0. So since I got it's equal to 0, I know that there's going to be one real solution. So I want you to try these and figure out how many solutions there are. So now let's find the number of x-intercepts. Now here I know that x-intercepts is the same thing as solutions, so I can go ahead and use my discriminant to figure that out. So I use my b squared minus 4ac, substitute the values that I have, and simplify. So here I ended up with a negative, so I know that I have no real solutions, which means I have no x-intercepts. Okay, so I can use my graphing calculator to just double check, and I see that when I graph this equation, it never touches my x-axis, so I know that I have no intercepts there. So now here I want you to try these and see how many x-intercepts, or solutions, right? Those two are the same thing. Figure out how many each of these functions has. So now we're looking at our last learning target, figuring out some methods for solving quadratic equations. So we've learned all of these different methods. The first method we learned was factoring, and this was back in Unit 7. So sometimes you'll notice that some of them are easy to factor, and it's really straightforward when I can notice that. The disadvantage is some equations just are not factorable. So I know if I can't look at it and factor it immediately, just to go ahead and not even try this one. The second method we tried was graphing. So when I graphed it, I could see the number of solutions. When approximation is good, then I can go ahead and use my graphing. And another thing is I can use a graphing calculator or Desmos to help me with this. So the disadvantage here is it won't necessarily give us exact solutions. And most of the time we want those exact solutions. The next part in lesson 9.3 we learned was using square roots. So it's easy to solve these equations when I just have a simple x squared equals d, and this d is just some number. So I can only use square roots for certain equations. Then in 9.4 I learned how to complete the square. So this I want to use often when a is 1, right, when that x squared term is 1, and then if b is even it works pretty well. So sometimes this can be really difficult calculations, so that's why it may not be the best way to do this. And now today we learned about the quadratic formula. So the quadratic formula, like I was saying, can be used for any quadratic equation, and it will always give us exact solutions. It can just take some time to do those calculations often. So we always want to think about which one of these is best in solving our quadratics. So let's go ahead and look at a couple of examples. So solve the equation using any method and explain your choice. So let's look here at A. So here I have an A term of 1 and my B term is even. So I want to go ahead and complete the square here. That'll be the easiest way. So I write my original equation, I complete the square, right? So I divide this middle term by 2 and square it and add that to both sides. Then I write the left side as my squared binomial, so I factor this left side. Then I take the square root and I add 5 to each side. So now I've completely simplified it. So now let's look at B. I've got 2x squared minus 13x minus 24 equals 0. These are pretty big numbers. I can't automatically factor out 24. This just does not look factorable, so I'm going to go ahead and use my quadratic formula. So I write my quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. Then I go ahead and substitute my values in, and I can simplify. I figure out, is this a perfect square? Which it is. 361 is a perfect square. So my solutions are 13 plus 19 divided by 4, and then 13 minus 19 divided by 4. So my two solutions are 8 and negative 3 over 2. So now let's look at C. So I've got x squared plus 8x plus 12. Well, this to me looks like I can go ahead and factor it pretty easily because I know that 6 times 2 is 12 and 6 plus 2 is 8. So I'm going to go ahead and factor this one. Okay, so I write my equation. I write it out factored, right? And like we said, 6 times 2 is 12 and 6 plus 2 is 8. Then I use my zero product property, setting each piece equal to 0, and then I solve for my x. So I have my two solutions at negative 2 and negative 6. So you always want to just double check and see which is the easiest way that I can figure this out and solve it. And that's the way you're going to want to do it. So now I want you to the big thing here is to tell me which method are you going to use and kind of why. That's the biggest thing with these. So now that we've looked at everything, let's look back at our learning targets. So first we were able to solve quadratic equations using the quadratic formula. Here it is. This needs to be in your memory banks just all the time. Then we looked at the discriminant. And remember, the discriminant is the stuff that's under the square root sign in the quadratic formula. And this discriminant will help tell us how many solutions we're looking at. Then thirdly, we looked at efficient methods for solving quadratic equations. Which way am I going to use and why does that way make sense? So now that we've gone through all of these learning targets and these examples, go ahead and work on your homework for 9.5.